Welcome everyone for today's class. Yesterday we have discussed about what is co-precipitation and what is post-precipitation. And we know what is post-precipitation and co-precipitation. In this class, we are mainly focused on peptization. Before going to discuss about the peptization, we shall see differences between co-precipitation and post-precipitation. The contamination or impurities in post-precipitation gets increased when when the post-precipitation occurs in the gravimetric analysis. It leads to increase in impurities, but in co-precipitation it leads to decreases. And the contamination increases in post-precipitation by mechanical or thermal process, but in co-precipitation digestion, but in co-precipitate contamination is decreases. The next one, the magnitude of contamination by post-precipitate much be greater in co-precipitate. So these are the differences between co-precipitation and post-precipitation. And we shall see clearly about clear differences between the co-precipitation and post-precipitation now. In co-precipitation, the first difference, it decreases with time when the precipitate is allowed to be in contact with its mother liquor. If there is the contact between the precipitate is contact with the mother liquor is longer time or increase, time is a year, then there is decreasing of co-precipitation. But the post-precipitation increases during the contact is increased, the precipitate and the mother liquor. The next one is it decreases when the solution is stirred or heated. The co-precipitation decreases when the solution is stirred constantly and slow addition of the reagent. By heating, it decreases. But post-precipitation, it increases when the solution is stirred or heated during. The next one, the amount of substance co-precipitated is far less, but the amount of post-precipitation is much more. Now we know what are the differences between co-precipitation and post-precipitation. Next, I shall move on to the topic, that is peptization. What is peptization? What is peptization? Peptization is a process by which a precipitate is converted into colloid. Here, the normal precipitate is converted into, it may be in the crystalline form or in the coagulated form. It is converted into the, if it is a coagulated form, it is converted into colloid. Here, the precipitate gives a colloidal form. The process of conversion of this is called peptization. This peptization may be done in two ways. One is we can do this peptization by adding suitable ions or by adding the dispersion medium. If we follow these two ways, we can do the peptization in the solution or in the precipitate. First we shall see peptization by ion. How we do peptization by ions, by using ions. In this method we are going to do the peptization by using ions. In this method, a small concentration of an electrolyte is added to a precipitate and in the presence of the dispersion medium. The ions present in electrolyte act as peptizing agent. So we get colloid, and in this process, the precipitate particles absorb suitable common ions from the added electrolyte. Their boundary potentials are raised. So they are dispersed into the medium as a result of the electrostatic repulsion of the adsorbed ions. Here, electrostatic repulsion is taking place if you do peptization by ions. Therefore, in this method, a small concentration of an electrolyte is added to a precipitate in presence of the dispersion medium. The ions present in the electrolyte act as peptizing agent and get collide. In this process, the precipitate particles absorb suitable common ions from the added electrolyte so that boundary particles are raised. Therefore, they are dispersed into the medium as a result of electrostatic repulsion on the adsorbed ions. For example, freshly precipitated silver chloride is peptized by a solution containing chloride ions. Here, for example, sodium chloride we have taken in the solution. Here in this example, the precipitate formed is silver chloride. If we had sodium chloride in this precipitate, then it gets colloidal form by dispersion, or the solvent. Therefore, in this example, the chloride ion is used as a peptizing agent, which when it is present in the solution and it precipitates a silver um, into silver chloride collide. Silver precipitate is converted into silver precipitate collide. Then we had sodium chloride in this, the solution containing the silver chloride precipitate. And another one example is freshly prepared ferric hydroxide precipitate is washed with small quantities of ferric chloride solution. Ferric hydroxide colloids is obtained. If you have when the freshly prepared ferric hydroxide precipitate is washed with small quantities of ferric chloride solution, this is ferric chloride solution, what happens here is that this ferric chloride hydroxide precipitate is converted into ferric hydroxide collide. So these are the examples for peptization by ions. Here we discussed two examples. So one is the silver chloride is the precipitate is converted into silver chloride collide by use of chloride ion, and the another one is ferric hydroxide precipitate is converted into ferric hydroxide collide use of ferric chloride solution. Next one, peptization by dispersion medium. In this method, a precipitate is converted into sol, that is, sol means it's a colloid, Sol means, here we have a word which means collide by simple shaking it with the dispersion medium. That is, the precipitate is converted into collide by simply shaking it with the dispersion medium. By this method, we can prepare lyophilic colloids or salts. For example, gelatin is peptized by water. It is an example for peptization by dispersion medium. By using this method, the peptization is used for preparing both uh, lyophobic as well as lyophilic colloids. Preparation of lyophobic and lyophilic colloids. Here, uh, lyophobic and lyophilic colloids are formed by using these methods, that is peptization by ions and peptization by dispersion medium. By peptization by ions, there is a formation of lyophilic colloids. In peptization by dispersion medium, there is a formation of lyophobic colloids. So what is lyophilic and lyophobic colloids? Here we have a word that is philic, that is called love or the attraction. Lyophilic colloid means if there is an attraction between solvent, I mean, that is lyophilic colloid, also called as water loving colloids, that is solvent loving colloids. Here lyophobic colloids, which means the colloid which are hate the solvent molecules, which means there is not any contact with the solvent molecules. Therefore, lyophilic colloids means also called as solvent loving colloids. Lyophobic colloids is also called as solvent hating colloids. Then we have discussed about the peptization by ions as well as peptization by dispersion medium. We shall uh, uh, explain. I shall explain some more. I will give some more explanations about the peptization by dispersion medium, which means we know what is peptization by dispersion medium. The process of converting appreciate, uh, precipitate into a colloidal sol, that is, or colloidal solution or colloid, by shaking it with the dispersion medium in the presence of a small amount of electrolyte is called called peptization by dispersion medium. And that is, here we are using an electrolyte that is called peptizing agent. So the electrolyte which is used to um, um, involved in the peptization is called peptization peptizing agent. This method is used to convert a freshly prepared precipitate into a colloidal sol. So in the peptization dispersion method, a freshly prepared precipitate of the substance is made to pass into the colloidal state by the addition of a suitable electrolyte. Already I told that the adding electrolyte is called peptizing agent. The process of dispersing a freshly prepared precipitate into colloidal form by using a suitable electrolyte is called peptization. The electrolyte added is called peptizing agent. In peptization, the larger particle is dispersed into smaller particles in a colloidal size by adding a particular electrolyte which act as a dispersing agent. For example, sediment of aluminum hydroxide will change into a colloid by adding a solution of aluminum chloride. Nickel sulfide will change, this is into, this is not chart, this is change into colloid when it is added into hydrogen sulfide. and sediment of silver chloride will change into this also charge, that is change into a colloid by hiding a solution of ammonia. So these are all some of the examples for peptization by dispersion. The dispersion method not only used in the peptization, it is also used in some other methods. Um, they are given here. Mechanical dispersion method, the substance is first ground into coarse particles, and electrical dispersion method, it is used to prepare a sol of platinum, silver, copper, or gold. In the peptization method, already we have discussed. And then homogenization is any of the several processes used to make a chemical mixture the same throughout. If you want to uh, prepare a homogeneous solution, that is homogenization by peptization method, uh, dispersion method. Now we know what is peptization and how we do peptization by ions and peptization by dispersion method. Here we shall see um, some some of the things we have to do while we are doing peptization. So we know what is peptization. That is, yeah, peptization mainly does is that it reverses the coagulation in which a coagulated particle reverts to the small particles, which converts into the smaller particle. So while rinsing the precipitate to remove this residual material must be done carefully to avoid significant losses of the precipitate. So when we do the peptization, we should be careful that uh, when we are rinsing the precipitate to remove this residual material, and then during filtration removes most of the supernatant solutions, so that we should be careful. Usually the rinsing medium is selected to ensure that solubility losses are negligible. In many cases, this simply involves the use of cold solvents or rinse solutions containing organic solvents such as ethanol. Precipitates containing acidic or basic ions may be experience solubility losses if the rinse solutions uh, pH is not appreciatably appreciately adjusted. When coagulation plays an important role in determining particle size, a volatile inert electrolyte is often added to the rinse water to prevent the precipitate from reverting into smaller particles that may not be retained by the filtering device. So this process of reverting to small particles is called as peptization. So simply we said that already. The peptization is the conversion of the precipitate into the colloid. Here we are given the um, definition detailing. The volatile electrolyte is removed when drying the precipitate. So while we are doing the precipitate or while we are drying in the gravimetric analysis, if we do the peptization, the volatile electrolyte is removed. If you do the peptization, the volatile uh, that is electrolyte, if it is present in the solution, which is removed. Generally, solubility losses are minimized by using several small portions of the rinse solutions instead of a single large volume. So if you have the smaller portions of the precipitate, then it will be the solubility increases. Then testing the used rinse solution for the presence of impurities is another way to ensure that the precipitate is not over rinsed. This can be done by testing for the presence of a targeted solution ion and rinsing until the ion is no longer detected in a freshly collected sample of the rinse solution. Finally, after separating the precipitate from its supernatant solution, The precipitate is dried to remove any residual traces of rinse solution and any volatile impurities. Um, a temperature of we have to maintain the temperature around 110 degrees Celsius, that is the 110 degrees Celsius is usually sufficient when removing water and other easily volatilized impurities. A conventional laboratory oven is sufficient for this purpose. Suppose if you are precipitators used in the higher temperatures, precipitation in higher temperature require the use of a muffle furnace or a bunsen or a maker burner, and are necessary when the precipitate must be thermally decomposed before weighing or when using filter paper. But if you are the precipitated in gravimetric analysis, if you are used the precipitant is a organic compound, there we could not use this high temperatures. If you are using the in if you are estimating the so precipitate or sorry ions or the substance using inorganic precipitant, we can go for at higher temperatures. And we should ensure that drying is complete. The precipitate is repeatedly dried and weighed until a constant weight is applied. We should ensure that uh, when you are drying, when the drying of the precipitate is completed or not. Precipitates containing volatile ions or substantial amounts of hydrated water are usually dried at a temperature that is sufficient to completely remove the volatile species. An additional problem is encountered when the isolated solid is that is non-stoichiometric. So what means unbalancing? For example, precipitating manganese ion as manganese hydroxide followed by heating. To produce the oxide frequently produces a solid with a stoichiometry of manganese oxide. That is the formation of a mixture of several oxides that differ in the oxidation state of manganese. In this class, we have discussed what are the differences between co-precipitation and post-precipitation, and what is peptisation, and it is a process by which a precipitate is converted into colloid. And we discussed uh, what are the ways to um, do the peptisation. We can peptisation by adding suitable ions, or we have discussed about peptisation by dispersion medium. This is peptisation by ions, and example for the peptisation by ions given, and peptisation by dispersion medium, and the uses of peptisation by ions and peptisation by dispersion medium. Also, we have discussed this class, and we have discussed what are the um, things we have to do to avoid impurities during peptization. Um, these are the things we have discussed. Therefore, we know that what is peptization and what are the methods to adapt to do the peptization and so on. Thank you.